Let's take a look at the cosine function. Remember, the cosine function looks something like this. The cosine of 0 is 1. Cosine of pi halves is 0, etc. Now remember, we defined the arc sine in the earlier lecture. What I'm going to try to do is define the arc cosine in this lecture. Well, let's first notice that cosine is not a one-to-one function. It fails the horizontal line test. So like the sine function, we are going to try to restrict the domain of the cosine function. So how about if we just talk about the cosine function between 0 and pi? That would give us just this little piece. Notice this little piece of the function is actually a one-to-one function. So we're going to define cosine x between 0 and pi. Okay? So note, if we let f of x equal cosine x on the interval 0 to pi, then f is a one-to-one function. It passes the horizontal line test. Therefore, since this is a one-to-one function, there exists an inverse function, and we'll define the inverse as cosine inverse of x. Or you'll hear me refer to it as arc cosine. These are the exact same things. Okay? So this is going to be our function that we're going to talk about first. Here's the cosine function. Okay, we've eliminated all the other stuff. That function's one-to-one, and so there's an inverse function. Let's take a look here. The domain of our one-to-one cosine function is 0 to pi. The range is -1 to 1. Okay? Therefore, the inverse function, remember the domain and range simply interchange. The domain of the inverse is going to be -1 to 1, and the range will be 0 to pi. And I'll take a look at that graph here in a moment. So let's write this down. For given f of x equals cosine x on this domain, it's 1 to 1, so it has an inverse function. The domain is 0 to pi. The range is -1 to 1. Therefore, the domain and range of the inverse function will just be the range of f, and the domain of f will be the range here. Okay, so let's take a look at what this function looks like. Here's the arc cosine function. Okay, the domain is from -1 to 1. The range is from 0 to pi. This would be pi halves. Okay, remember, for example, cosine of 0 equals 1, right? Therefore, arc cosine of 1 must equal 0. On the other hand, let's say cosine of pi halves is equal to 0. Therefore, arc cosine of 0 is equal to pi halves. That's why we have a y-intercept at pi halves. Arc cosine of 0 is pi halves, etc. So there's the graph. Okay? What you need to write down is this. We're going to define the arc cosine, x, as the angle on the interval 0 to pi, whose cosine is x. So just like the arc sine function, we're going to do the same type of thing. I'm going to give you a number in between -1 and 1, and you're going to find the corresponding angle. So let's figure out, what is the angle whose cosine is -1? Okay? So what is the angle on the interval 0 to pi? So we're looking for some angle here, such that the cosine is equal to -1. Well, we know that the cosine of pi is -1. Therefore, the arc cosine of -1 must equal pi. Okay? Let's try this one. Evaluate cosine inverse of -1/2. So let's look for the angle on the interval 0 to pi, so an angle either in quadrant 1 or quadrant 2, whose cosine is -1/2. Well, it can't be over in this quadrant because everything over here is positive. So it's got to be an angle somewhere over there. So we need to figure out the angle whose adjacent over hypotenuse is -1/2. And of course we know that that's one of our special right triangles. So this is an angle here of pi thirds. So the arc cosine of -1/2 must be this angle, which is going to be 2 pi thirds. Okay? All right, you'll get lots of problems on your homework like that. All right. Finally, let's look at this. Remember, the cosine and arc cosine are inverse functions, so this property must hold. Cosine of arc cosine is x for all x in the domain of the arc cosine. And arc cosine of cosine x is x for all x in the domain of cosine. For example, cosine of cosine inverse 1/3 is 1/3, since 1/3 is in the domain of arc cosine. Okay? Let's try this one. Arc cosine of 7 pi halves. Well, first note, 7 pi halves is not in the domain of our 1-to-1 function cosine x. Remember what our function looked like. Looks like this here. 7 pi halves is way over here somewhere. Okay? So we cannot say that the arc cosine of cosine 7 pi halves is 7 pi halves. That's not true. So how are we going to do this problem? Well, let's figure out what the cosine of 7 pi halves is. Cosine of 7 pi halves, if we look at a circle, we've got 1 pi halves, 3 pi halves, 5 pi halves, 7 pi halves is here. So the cosine of 7 pi halves is 0. So this simplifies to arc cosine of 0. Okay. Now, what is the angle whose cosine is 0? Well, on the interval 0 to pi, the only possible angle is pi halves. So it's very important that you can evaluate sine, cosine, tangent at a given angle, because that will help you when you do these inverse problems. The next lecture will define the arctangent function. Okay, that's very similar to the arcsine and arccosine. Try a handful of these problems before you view the next lecture.